Here, you're watching my lesson on gears. This lesson will be relatively short. It'll only talk about gears and what they are. The reason why we talk about gears is because we see these types of machines in almost every other type of complicated machine. Any machine with complex moving parts will employ gears in order to do the jobs that they're meant to do. So, what is a gear? A gear, simply put, is a wheel with teeth. So we have the wheel right here, and we got all of these teeth coming out from the wheel. And so what happens is, typically you'll find one gear linked up, teeth, with another gear. And so if you have more than one gear linked up, this is called a gear train, a train of gears, right? You can see this gear, this gear, this gear. They're all linked up, and so you will have something called a gear train. If the gears were instead connected by a chain rather than being directly linked together, then we'd call that a sprocket. So if the gears are directly touching, we call that a gear train. And if the gears are connected by a chain, it's called a sprocket. So you've probably seen this if you've seen a bike, right? You'll see one large gear where the pedals are and one small gear connecting to the wheels, right? So as you pedal, this causes this gear to spin, which pulls on this chain, causing it to rotate, which is causing it to also pull on the smaller gear, causing that gear to rotate. So gears connected by chains are sprockets, and gears connected together directly are called gear trains. So what's the point of gears? Well, there are two main features of gear trains and sprockets. You have your driver gear and your driven gear. Your driver gear is the one that force is applied to create the initial spin. As that one spins, all gears related to it, connected to it, or chained to it will then also spin. Now, you may notice that as this gear is changing and rotating counterclockwise, the gear directly after it will spin clockwise. So each gear following the next will spin in the opposite direction. Gears spin in opposite directions from the ones next to them. So the driver gear applies the force on the driven gears. The size of the gear can affect the speed of each gear that follows. So if you have a very large gear attached to a smaller gear, that can affect the speed at which the gear train moves. So if the gear applying the force is much larger than the smaller gear, so in this GIF we have 60 teeth in this gear. So each tooth, there's 60 in total on this big wheel or gear, is connected in this gear train to this smaller gear of 30 teeth. Well, how can we know how fast the small gear is spinning, or how fast or how much of an effect does the big gear have on the small gear or the driven gear? Well, we call this difference the speed ratio, right? The driving gear will increase the speed of the driven gear, because if you look at this gear, it's big, right? So for it to make one turn, this gear would need to make 2 turns, because there's twice as many teeth in the large gear. And so we can call this ratio the speed ratio. This is called the speed ratio. You look at the number of teeth, you count the number of teeth on your driver gear, right? So in this case, A is our driver gear. We have 60 teeth, and we divide it by the number of teeth on the driven gear. This is called the speed ratio. So because this has 60 teeth, so we'd go 60 for the driver gear, 60 teeth, right? And we divide that by the number of teeth on the driven gear, which would be 30, which would make it 2. So we have a speed ratio of 2, meaning that the driver gear is making the driven gear move twice as fast. And you can see that. As this one rotates once, this smaller gear will rotate 2 times. And so that's basically how gears work in a nutshell, as they've chained up and used in regular machines. So in the next lesson, we'll be talking about pulleys and how they can affect machines and how they can affect the amount of force required to lift objects.